Alright, welcome to this video about graphing polynomials. I'm Mr. Nair. So what we're going to do is we're going to go through the 3.5 notes here, and hopefully this will help you to understand the main ideas and concepts that we're going to discuss here in this section. So just to give you a preview, what we're going to talk about in this video is how to graph a polynomial, mainly looking at some of the key features of the graphs of polynomials, and how are they similar, how are they different. We're going to look at how do we find the x-intercepts and the y-intercept, how do we find the end behavior, or how do we draw the end behavior, and then also we're going to look at what's called multiplicity with some of these polynomials. So what I'd like you to do first is, hopefully you have these notes already pulled up while you're watching this video, but what I want you to do is I want you to take a look at the first graph that's on our page here. So notice that our first graph here is this this x squared. Let me see if I can just use a pointer here. So this graph right here, right, where we have the x squared. And I want you to take a look at it and compare it with graph number 3 here, and then also with graph, let me see if it'll let me scroll down here. There we go. Yep. And then looking at also graph number 5. So this graph right here. Okay. So I want you to take a look at those, and I want you to see what's the similarity between those graphs, and see if you can identify any similarities. How might they be related to each other? And so I'll give you a moment to do that. So you might want to pause the video while you're looking at those and kind of consider how they might be related to each other, and then we'll come back together. Okay, so hopefully you've had a moment to reflect on those. So I don't know if you noticed this, but I'm going to point this out. When we looked at these graphs here, one thing that we may have noticed is that number one, notice that with our x squared graph, this number 1 graph, that the graph is going up in this direction, right? And it just seems like it's going to probably go on forever and ever as we go up. And if you'll notice with graph number 3, that's doing the same thing, right? It's kind of going up that way. And if we look at the graph number 5, it's doing a similar thing, but you'll notice that instead it's going, both parts are going down, right? And so they're going to go on forever down in that direction, okay? Also, I was going to point out that you'll notice that both of these graphs have this kind of curve shape, right, where it's kind of coming up and around. Also notice that on these graphs we have a similar thing where it's curving kind of in these directions. And let me come down here. Same thing right here, right? It's curving. This looks kind of like an M, right? The one up above is like a W, okay? So those are some similarities that I noticed right off the bat. Now let's take a look at graphs number 2, 4, and 6. And let's see how are these graphs related to each other, right? So we're first going to look at this graph of x to the 3rd power, or x cubed. And then let's take a look at the graphs. Unfortunately, when I printed this, or when I say this as a PDF, the equations kind of got moved down to the bottom. But this is graph number 4, this one right here. And then this is graph number 6, right? And so I want you to take a look at graph number 4 and number 6 and compare them with graph number 2. And see if you notice anything that is similar between those ones. And so I'll give you a chance to kind of pause the video, take a look at those, and see if you can notice any similarities between those 3 graphs. Okay, so hopefully you've had a moment to look at those and see if you can find any similarities. So notice that with our x to the 3rd power graph, or x cubed graph, that in one end it's going up and going on forever, and the other end is going down and going in forever in that direction, right? And if we look at graphs number 4 and 6, we have a similar situation going on, right? where we have this graph is going off forever in that direction, then it's going, the other end is going off forever in that direction, and graph number 6 similar, but maybe it's a little backwards. Okay. And so if you notice too with these graphs, they also have similar curves where it kind of comes up and then comes down. Same with this one over here, right? We have these kind of going up, then going down, then coming back up, right? Just like we do with our original x cubed graph, where it kind of comes up and then it swings back up, right? So hopefully you've recorded some of those things on the notes here. But what I want to do is I want to look at questions number 3 and 4 on here. So question number 3 asks, what do you think is the connection between the graphs 1, 3, and 5 and their equations? So now that we've kind of looked at the graphs themselves, I want you to take a look at for the equation for graph number 1, which was our x squared graph, right? And I want you to compare it with the equations on graph number 3 and graph number 5, right? And see if you can see anything in the equation that might have a connection between the graphs here. Okay, so I'll give you a moment, maybe pause the video, see if you can determine what might be the connection between the graphs and their equations, why all those are similar to each other based off of their equations. Okay, so hopefully you've at least had a chance to kind of think about it. Notice that on our x squared graph, notice that the power on our x squared is 2, right? And 2 is an even number. And if we look at the other equations, so looking at number 3 here, notice that the power that's right out in front, the highest number on 3 is a 4, which is also an even number. And if we come down and look at number 5, let's see if there's something similar. Yes, and in fact, on number 5, we have that 4 there, right? So it turns out that when we have a polynomial that has an even degree, so remember we talked about that in the 3.1 notes, when they have an even degree, then it means that our graphs are going to have some of that same similar shape to the x squared graph, where we have end behavior that looks something like this, right? Or you'll notice that one of them had end behavior that kind of looked like this, right? Or is coming down instead. And so it's because they have an even degree. Oh my goodness, it's not writing super well. Degree. Okay. That they have that same similar shape. So if we were to take a look then at graphs number 2, 4, and 6, let's see if there's a similar connection between those graphs. So let's take a look at the degree on number 2 here. So the power we have is 3, right? So the degree is third degree. And 3 is an odd number, right? It's not like 2 or 4 or 6, right? It's an odd number. So let's see if our other equations have a similar situation here. So if we go down to 4 and 6, oh, in fact, yeah, let's take a look at that. Our degree on those other 2 graphs is a degree 3. And so that means that it's also an odd power, an odd degree number. And so the connection then would have to be that they all share, clearly they all share the same degree, right, degree 3, but they're all odd numbers, right? And so we're going to get the shape of a graph that looks something like this, or you'll notice that one of them kind of had a reverse one that looked like that. And so it's because they have an odd degree, right? Odd degree. That they have that same shape, right? Where we have the kind of one end going up and one end going down. Okay, so I've kind of already drawn it here, but this might be helpful to help you keep track of this. So here we now get into this thing called end behavior, right? And we kind of talked about this a little bit in the 3.1 notes. But what I want you to do is draw what the end behavior looks like for each type of the polynomial graph that we've looked at up above. So remember that up above here we have, for our degree, let me change my color here. So the top row here, whoops, let me scroll. So this represents the degree. Oh my goodness. Degree. All right. It represents either even or odd, right? The degree number. And so here on the left-hand side, notice it says positive and negative. So if you notice from looking at those graphs up above, on a few of those equations, there was a negative sign out in front of where our degree was, right? And so that's what this is referring to here, is if it's positive or negative on our leading x variable that has the degree on it, right? And so, and we call that, first thing, if you remember, we call it a coefficient, whatever is right there in front of our variable. And so this is referring to the coefficient, the thing that's right out in front of our leading, well, in fact, it's can't spell, coefficient. Here, let me erase that. Coefficient. Okay. Let's try this again. And I might just have to write slower. There we go. Coefficient, okay? So either if it's a negative sign, if it's positive, so I mean there's no negative sign out in front, or if it's a negative sign that's out in front, right? And so as it turns out from what we saw up above, and I kind of already drew these, we end up having on graphs where we have an even degree, when it's positive out in front, the end behavior looks something like this, right? Where the graph goes up towards positive infinity in the y direction, right? When it's an odd number and it's positive, notice that the graph has one end going down towards negative infinity this way, and then the other part of the graph is going up to the right into positive infinity. Now, when we put a negative sign out in front, though, we get something a little different. In fact, we get the opposite. When it's negative and even, notice that the arrows went down, right? Or the graph is going down towards negative infinity. And then when it was odd, and it was negative, the arrows just reversed, right? So instead of going down towards negative infinity on the left, now the left is going up towards positive infinity, and on the right, the graph is going down towards negative infinity. So the arrows just kind of swap, or in other words, the direction the graph is going, they just kind of swap there, okay? All right, so now let's take a look at the x-intercepts for each of the graphs. So remember that the x-intercepts are the places where the graph crosses the x-axis, right? And so if we take a look at graph number 3, so let me scroll back up here. Graph number 3. If we take a look at where we cross the x-axis, notice that we're crossing here for one of them, here for another place, and then here at this one, and here at this one right here. So we're crossing at those 4 places. And so notice that we cross at x is equal to -2 on the far left, x is equal to -1, x is equal to 1, and x is equal to 2. So what I would do is I'd just come down here, and for my x-intercepts, I would say that my x-intercepts are x is equal to -2, -2, x is equal to -1, x is equal to 1, and x is equal to 2. So those are all my x-intercepts for that graph there. So what I want you to do is see if you can try and figure out what the x-intercepts are for graphs number 4, 5, and 6, and see if you can figure it out from there. Okay, so I'll let so maybe pause the video, see if you can figure those out on your own, and then so I will I will try to include on Canvas the answers for these notes, and then hopefully you can see what those other x-intercepts are. But that's essentially what you do to find those x-intercepts. So I'll pause the video, see if you can find those on your own, and then we'll come back together. Okay, so let's move on now. So let's now take a look at the x-intercepts themselves and what's happening with the graph as we get to each of those x-intercepts. So let's take a look at graphs number 3 and 4. It says, what do you notice about the graph at each of the x-intercepts for graph 3 and 4? So let's go back up to the top here. So if we look at graphs 3 and 4, okay, so I'm looking at graph number 3 here on the right, and looking at what is happening at each of those x-intercepts. So one thing I notice with each of those graphs there is that the graph just seems to go right through each of those x-intercepts, right? It seems like the graph is just going right through each of them. So in other words, we're crossing the x-axis at each of those x-intercepts. So then if I look down at now graph number 4, yeah, and it looks like it's the same thing is happening at each of those x-intercepts, right? So they're at 2, and then here at -1, and at -2. Yeah, it looks like we're just kind of crossing right through in our graph. So what I would say then is it looks like when we are at each of our x-intercepts, our graph is crossing the x-axis. Whoops, I was writing a little too fast. My iPad's having a hard time keeping up with my computer, or maybe vice versa. Okay, so we write this more slowly. Oops, we are crossing. Crossing. Okay. Oops, let me make this look more like an R. But hopefully you're watching this video on 2x speed, because I'm sure it's probably a little aggravating, especially if you're like, okay, I get it, let's move on. But that's why I apologize for that. But let's now take a look at graphs number 5 and 6 and see what's happening with the x-intercepts there. So let me scroll back up to the top. So let's see, graphs 5 and 6. Okay, let me change my color here. Let's go with this purplish color. Okay, so I'm looking at graph number 5 here. So it looks like here we are crossing at -3, but this is interesting. At this x-intercept, the graph doesn't seem to cross. It looks like it's either kind of touching at that -1 or maybe bouncing off the x-axis there at -1. That's kind of interesting. But then over here, yes, we are crossing. Okay. If we look over here at graph number 6, so we do cross there, right? But again, we have something interesting here. We have the graph either touching or bouncing right there at that 1. So that's kind of interesting. So what I would say is that we're kind of crossing at some points, but at some other ones, at some places we're bouncing off or touching the x-axis, right? So I'm going to put some, or I should say at some x-intercepts wow. We are, oops. Oops. Touching. And I mentioned or bouncing, right? Or bouncing. Oops. Okay. Interesting. Okay. So now if we looked at, for the graph number 5, the factored form of the equation is f of x is equal to negative x plus 1, all that squared, times x minus 1 times x plus 3. So what do you think is the connection between what happens to the graph at each of the x-intercepts and the factored form of the equation? Okay, so yeah, so this is graph number 5. So if we just look back at number 5 here. So we had x is equal to negative 3 was one of our x-intercepts, right? We have negative 1 is actually also one of our x-intercepts, and positive 1 is another x-intercept. So if we come down here, let's see if we can see how those might be related. Okay, so we have x plus 1, all that squared. So as we mentioned, one of the x-intercepts was x is equal to negative 1. And so that would have to come from this factor right here, right? Because to find the x-intercept from the factor, we would try to figure out, well, what is x plus 1? When is that going to be equal to 0? Oops, to 0, right? And so in order for us to get 0 from adding 1 to something, x would have to be negative 1, right? Now, I noticed up here that we have this 2 right up above the x plus 1 factor. So I wonder if when there's a 2 up there that we get this bouncing or touching happening. And then if I take a look at some of these other ones, we have x minus 1, and that doesn't have a 2 there, or x plus 3. But technically, these do have a power of 1 on them, because x minus 1 to the first power, that would just give you back x minus 1, and x plus 3, if you raise that to the first power, that just gives you back x plus 3. So I think probably what this is, and in fact, actually, as it turns out, this is what happens with the graph. So let me change my color here real quick. When the power or exponent on the factor is an even number, so remember we had that 2 there, and that's an even number, right? The graph will touch, or if you prefer the term bounce, right? Touch or bounce. Oops. At the x-intercept, okay? So, and as we noticed from up above, with the ones where we had the 1 on them, notice that we crossed there. So when the power or exponent on the factor is an odd number, the graph will cross at that x-intercept, okay? Now let's take a look here at our y-intercept section. So if we go, let's take a look at graph number 3. So if I scroll back up here to graph number 3, let's see. So the y-intercept is where we cross the y-axis, right? So let me change my color here. Use yellow. So I noticed that on graph number 3 here, our graph crosses the y-axis at 4, right? And so let's take a look and see, how does that 4 maybe relate to our equation up above? Do we see 4 anywhere in our equation? Well, we see in this graph number 3 that we do have a 4 as our degree, right? But we also have this 4 that's off to the right side, right? This plus 4 here. Now, if you remember with linear equations, the y-intercept was always whatever we were adding on after our mx. So remember the y equals mx plus b. Whenever we had a b term at the end, that was where we were crossing the y-axis. And as it turns out, with polynomials, it's the same thing. Whatever number we're adding on to the end, that's the number, or that's what our y-intercept is. So what I would say if we come back down here, let me scroll down more. The y-intercept for the graph, or for graph number 3, is y is equal to, and I'm sorry if the yellow is hard to see because it's a little darker. In fact, let me change to a better color here. Let's use let's use this dark purple. Let's start over again. So y is equal to 4, right, is what we found up above. Okay? So I'm sure you can try and find those for graph number 4, number 5, and number 6. And again, I'll hopefully put the answer key with this on Canvas so you guys can take a look and see the answer. Okay, so then down here we just have some practice. So what you would do here is that you're basically doing kind of what we were just doing up above, just to kind of summarize everything. So first you're trying to figure out what's going to be the end behavior for each one of these, right? Where's my graph going to be going off to? So if we take a look at number 1 here, for our end behavior, so let's see, so the degree on this polynomial is 3, so it's odd, okay, and then if I look at the leading coefficient here, there's a negative sign right there, so it's going to be odd and negative. So what that means is that my end behavior, my graph, is going to go off to the left towards positive infinity, and then off to the right, it's going to go down towards negative infinity. Okay, so there's my end behavior. Let's see, and then let me blue. Oh, and I think also with these, let me check because I wonder if these got messed up with the, yeah, so with the printing. So you're also supposed to actually graph these. So what you can do is you can use Desmos or a similar graphing tool to kind of figure out what the graph is. But let me just show you. So what you do is with your graphs, you'd want to make sure you draw those arrows, right? Or you put arrows on the end of the graph just to show that's going to go off towards that end, right? And also just write, so what you might want to also do is write down what the end behavior is. So because it's going to be odd, oops, odd, and oops, and negative, come on, negative. I have a hard time writing the word negative here with my computer kind of lagging a little bit. Okay. And then the next thing they want us to do is find the x and y intercepts. So the x intercepts you can find, as we saw up above, from when you graph the graph on either Desmos or some other tool, you can identify the places where it's going to cross the x-axis, right? And then what you would do is you would also want to find the y-intercepts. So remember that it's just whatever we're adding or subtracting off to the end. So we know that our y-intercept is just going to be y is equal to -2. Oops, -2. Okay. And then also you might want to identify the multiplicity. So does it touch, bounce, or does it touch or bounce, or does it cross at those particular x values? Okay. And so you want to do that for each of the graphs here. So hopefully this was helpful to understand these different concepts of end behavior and what determines them, and also how to find the x and y intercepts from the graph, and then also how we can, and from the equation of course, and then also how we can determine what this multiplicity idea is and what multiplicity is. So hopefully this was helpful, and good luck with being able to graph your polynomials.